Hey guys, welcome back to Code.org. Today we are solving the problem find all distinct combinations of a given length. This question was asked in the coding interview of SAP, Juspay, Wipro and even EPAM. Okay, so let's check what the problem statement is. It says we are given an integer array and we have to find all the distinct combinations of given length k. So let's see the example over here. When k is equals to 2, then you have to find all the subsequents, we can say in simple words, which are having length 2. We can see 1 2, 1 1 and 2 1. Okay, so you might be thinking that we can use a nested loop 2 times and the things will work out. But in this case, the value of k is 2. Not every time the value of k will be 2. If suppose we get value of k equals to 5, then if you use nested loops 5 times, and it will be n power 5. Is it worth it? No, it will obviously give you a TLE. Okay, so we have to use backtracking for this. So how backtracking will be useful and how it will work, I will show you with the help of an intuition over here. Okay, so here I have taken an array having 4 elements 1, 2, 3, 4 and the value of k equals to 3. Means I have to find all the array which is having length 3 and which are distinct. Okay, so I'll be creating a function, parameterized functions, which will be having 3 parameters, namely k, a list and a set. This set will contain the list. Okay, and when we will add the value of list into the set, whenever the value of k in the function we are passing becomes equals to 0, then only we'll add this. So let's see how the function is going to work and how the things are going to take place. Okay, first of all, we are pointing over here. One pointer is pointing over here and another pointer will point over here. Sorry, another pointer is also pointing over here currently. Okay, so is the value of k equals to 0? No. Value of k equals to 3. So we'll add this into our array list and we'll put the value of k equals to 3 in this case. Now we'll pass on these parameters to the next function. In the next function, we'll decrement the value of k by 1. The value of k will becomes 2. Is 2 equals to 0? No. So we'll here we have come over here now and we'll add this value 1 comma 2. Okay, now we'll pass it to the other function. We'll again minus the value of k by 1. K equals to 1. It points over here 1 2 and 3. Okay, 1 2 and 3. Now we'll pass our pointer down here to 4 and the value of k is 0. When the value of k is 0, what we will do? We have to add this value into a hash set 1 2 and 3, and whenever the value of k becomes 0, we will return back over here. Where we will return? We return back over here. A pointer will not point over here. We will return back over here and the value of k will become 2 again and we will delete this element. So where we are? Where we are pointing over here back again with value of k equals to 2. Okay, so again where will our pointer go? Now we will skip this part. We are not going to go here. This is backtracking. This is the beauty of backtracking. We will not go here and we will go to the other element where the value of k will become 1 and we will have 1 2 and 4. Okay, now we'll again pass it to the further element where value of k will become 0. The value of, because we have minus 1 minus 1 0, value of k, yes, it is equals to 0. So what we will do? We'll add it 1 2 and 4. Okay, now this got over, this got over, this got over. Now before going here, we backtracked for 4, backtracked for 3. Now we have to do it for 2. So what we will do? We'll remove 4. We'll remove this 2 now. We'll remove this 2. We'll remove 2. We'll remove 2. What will the value of k? The value of k is now 2. And where it is pointing? It is pointing here. We are skipping this now. First of all, we skipped 3. Now we are skipping 2. This is backtracking, guys. This is backtracking. If you don't understand backtracking, then it is very complicated for you guys in competitive programming. So you have to understand backtracking. This is what backtracking is. Okay, so now k is 2 and I will add over here 3. Okay, now the pointer will come over here. From here, the k value will become 1 and we will add 1, 3 and 4. Again, now it will pass to the function where this parameters and k equals to 0. When the k is equals to 0, what we are going to do? 1, 3 and 4. Simply. Now backtracking again. Backtracking, guys, backtracking. Okay, what we are backtracking? We are removing this 4. Perfect. We are removing this 3. Perfect, perfect. And now we are even removing this 1. Why? Because see, we had come till here. Now what is left to remain? This 1. Okay, we have traversed all this pointer for 2. Now we have to backtrack for 1. Means we have to remove this 1 and we have to move to the next element. So our list is empty. Finally, our list is empty. And our pointer is pointing over here. And even a second pointer is pointing over here. It means the pointer which you will be sending for the functions. So value of k is 3. So you will add this and pass it to the function. This pointer, this will go here. What is the value of k? 2. We will add. Okay. What is the okay, again we will pass here. Value of pointer. Value of k 1, 2, 3 and 4. Okay, now we will again pass it to the function ahead and k will become 0 over here. K will become 0. It means we have to add 2, 3, 4. We did. Now it's time for backtracking, guys. Backtracking again backtracking. Now this time what will happen in backtracking? We'll pop this 4 out. Okay, when you are popping this 4 out, the value of this is 2. Now where we have to point? We have to point to the element next to the 4. Is there any element next to the 4? No, it's not going to happen. It's the end of the loop over there. So what we will do? We'll again come over here. We'll come to 3 and we'll come to 2. Now we'll backtrack for 2. We will backtrack for 3, but there is no element present ahead of 4. So again we are coming back and backtracking for 2. Now pointer is pointing over here. Value of k is 3. So we will add 3. Okay, the pointer goes over here. Value of k is 2. Okay, we will add over here. Value of k is 1. But there is no element. It is the end of the loop. We can't, we just have to backtrack now. But we cannot add any elements to a hash set. Why? Because value of k is not going to become 0 at any point of time now. So again, we'll backtrack for 4 in the same manner. And that will be the end of the loop. And this is how we are going to get our final output. Okay. So guys, if you didn't understand the intuition, you let me know in the comment box. I will again explain it to you with another example and with a more great thought process. So let's look at the code. So now guys, let's look at the code. Here I've taken the same example 1, 2, 3, 4 and even value of k equals to 3. I have called a function find combinations. I am passing the a, the array and the k. Okay, over here what I am doing is I'm creating a hash set, as I mentioned, an array list. Even I'm just creating it, not creating it really. I'm just creating a new object in the parameters, and I'm passing it to the function over here. So this is the base condition. If the length is 0 or if k is greater than the length of the array, then we are not going to get any output. Now the base condition to add the array list into the set. When the k becomes 0, then you go to backtrack for another elements. And here I am even passing the pointer, as I said, the next pointer. We'll start traversing from that very pointer. Okay, the next pointer which we are passing, we'll add that element into a list, and we will call the function, as I said, c, for the next element, j plus 1, and we will decrement the value of k, and these are two parameters. Now you might be thinking that backtrack, see, as I mentioned, backtrack. Whenever the function is returned from here, where it goes here. The point when I am saying that we are removing the last element, suppose this element 4, this is getting deleted. How we are deleting that element? Here, with this function. This is where the backtracking takes place. Okay, and then I'm simply returning the array which is getting printed out. Let's run the code. See, it's the same order: 1 2 3 1 3 4 1 2 4 2 3 4. So thank you for watching this video, guys. If you are finding this content useful, please like and subscribe to this channel, and stay safe.